Hey, this is Joe, Graybench Electronics. Welcome back to the pedal teardown series where I take apart new and interesting pedals and show you what's going on inside. Today we have the Huge Atreides. All right, we got the Atreides, which is the analog weirding module from Huge Electronics, which is a pedal company by Jeorge Trips. Huge has been around for a long time. They're one of the OG boutique pedal companies. They seem to have sort of disappeared in like the 2000s, at least that was my impression, but they're now back with a whole line of pedals and some new stuff, including this pedal here. So Atreides is a homage to the Dune franchise. The Atreides was the name of the family that, well, I'm not gonna spoil it, but it's the last name of the main character of the Dune series, and the name for the family, and also the analog weirding module. I didn't know this one. Apparently this is it was a weapon or a device in the David Lynch version of Dune, his screenplay or movie that came out. Anyway, this isn't about Dune, it's about the pedal. If I were to describe this pedal in more like pedal terms, I would call it an auto-wah sub-octave fuzz. So it sort of does all three of those things together. You have the auto-wah, so it's like a very tight bandpass filter that you can sweep up or down. For a wah pedal, you do it with a foot pedal, but for an auto-wah, it sort of senses how hard you pick, sweeps up and down that little notch or tight bandpass, so you get the wah sound. Sub-octave, meaning you have a octave lower than the primary note you're playing. In this case, the pedal, there's a little switch inside. You can switch between 1 octave down or 2 octaves down. And then fuzz, of course, is fuzz. It's a very saturated, thick fuzz, sort of reminiscent of like an op-amp big muff kind of sound. On top of the pedal, we have, instead of potentiometers, we have sliders, which essentially work the same way. You can slide up or down. You have contacts on either side, and then a wiper control. It's the same idea, it's just linear rather than rotary. These sliders have a little LED inside, so when it lights up, you can see. Let me see if I can demonstrate that. When you have power applied to the pedal, the sliders light up and show their position very easily. So if you're on a dark stage, you can look over and see the current state of your sliders. There's also no LED just for indication. The slider lights either turn on or off depending on if the pedal is bypassed or not. On the bottom here, we have a 9-volt battery hatch. You push in the little tab and it pops open. You can add in your 9-volt battery there. Top side, we have our 1/4-inch input and output jacks, 9-volt DC jack. It is a PCB mounted DC jack there. And our power specifications. There are 4 Allen head screws here, probably holding in a PCB that's holding all the sliders. The foot switch feels not like a 3-pole double throw, it feels like a single pole, single throw. And there's not a real defined click like you get with other foot switches. It's a little softer thud. And a decent amount of actuation pressure. Not an issue because obviously you're going to be stepping on it with your foot, but it's not light compared to some of the other foot switches. On the back here, we have the enclosure screws to hold the enclosure together, and they're mounted with rubber feet. The enclosure itself is a folded aluminum enclosure that is brushed and painted, and you can see it's sort of a clamshell design where you have 2 O's and they fit together like that. That's how these enclosures are done. And the graphics on the top here appear to be silkscreen graphics. That's it for the exterior. Let's go ahead and crack the pedal open. All right, so we got a dual PCB setup, technically triple PCB setup. The foot switch is on its own little daughter board here, but there's not much going on. It's just soldered straight in. We got some header pins. All the PCBs are connected with wires and headers, which is fine. Makes assembly really quick and easy. So we have 2 main PCBs. This is the signal PCB, has all the auto-wah and the octave effect, and the fuzz is all in here. Input and output, as well as bypass switching with the included relay here, probably double pole, double throw relay. Part number is EA25SNJ. It's a Nexum relay. And probably some power supply filtering with the electrolytics here. PCB mounted 1/8-inch jacks. They're actually, I believe these are Dunlop branded. Yeah, the 1/4-inch jacks are Dunlop branded. And they are stereo switching jacks with a secondary connection contact for the ring connection. They're also molded. It's a little hard to see here, but compared to other 1/4" jacks, the top side is molded here to be thicker so that you don't have to use separate plastic washers. When you buy these style 1/4" jacks, they often come with extra 1/4" washers, so you can extend the 1/4" jack away from the enclosure to allow the nut to tighten against the enclosure rather than bottom out on the ring here. But in this case, they just molded effectively those washers straight into the 1/4" jack. And there's our header pin connection to go to the main board. On the main board here, it's sort of a see-through design. It's kind of nice. You can see like the copper underneath and the planes of copper, the pores where they're left in large spaces, usually to eliminate any type of interference. And that exists on both sides. The slider controls here, they have this nice piece of foam installed on top so that if dust gets into the slots on the enclosure, hopefully it doesn't make it down inside the potentiometer itself, where it could cause audible scratchiness or the potentiometer to stop working altogether. You can take that off. It's probably not a bad idea every once in a while, if you own one of these pedals, to take this off and just blow it like with an air duster. Just kind of clean it out like so. Like just the standard air duster here. Just get a little dust off. You see there's a little hair or whatever there. Caught that, did its job. Just give it a quick little blowout and then install it back on there. But yeah, you can see the sliders, they have a big open slot where dust could get in, and so it's good to block that off with something, which is what Huge did with the piece of foam here. So you can hopefully see there on the bottom of the sliders, there's a whole bunch of contacts, and that's because you have the potentiometer and you also have the LED. So at least 5 connections there. There, hopefully you can see how the LEDs sort of sit inside the slider and they illuminate on top when the pedal is activated. The slider resistance values are marked on the side here. This first one, which is the volume control, is 100K linear. The second one is 100K linear, 100K linear, 100K linear. The third one? The fuzz control is a 500K linear. Same with the rate control, and the sub control is a 100K linear. So all 100Ks except for the fuzz and the rate, which are 500K and all linear. And you can see how it's mounted here. It has little, about 1/4" aluminum standoffs that are more or less permanently screwed into the board. And then you just use the Allen head screws here to connect the PCB to the top side of the enclosure. There are, as you can see, a whole bunch of ICs on this board, and I went ahead and wrote down what they were. So going through here, 16-pin packages here, 1, 2, 3, and 4. These 4 here are all LM13700M, made by National Semiconductor. The 8-pin packages here, 1, 2, and 3. These are marked 33172, which is probably a date code or lot code, something like that. And then presumably a part number of PRN-O, or like O or Oscar, or PRN-0. The 14-pin package here is marked 14013BG, and then second line is AK, like Alpha, Kilo, 147, Mary, 18, AK14M18, and that is made by ON Semiconductor. And the larger transistor here, probably a MOSFET, is a JE210G. We also have a little trim pot here. This may be adjusting the width of the Q of the auto-wah, or perhaps a limit on the rate, either the slow or fast. And we have the octave switch over here, which is just a little surface mount single pole double throw switch, which is selecting either, it's marked lightly on the board here, but in the upward position it is -2 octaves down for the octave control or the octave effect, and in the down position it is -1 octave. On the flip side of the board here, there is at least one visible IC, and that is marked MZEX042, and that is a Texas Instruments. There's also a rectifier diode over here. It's one of the 4000 series 1N400 something. I can't see the last digit, but they're all the same diode, just different voltage ratings. That's pretty much it for the main board. As far as ICs on the input and output board over here, 8-pin package on top is a TLO61 dual op amp from Texas Instruments. Under that is a Texas Instruments CD4093BM. And the third package here I don't recognize. It's marked HEF4013BT. Second line is CYE83704. And third line is TXD20187. And it also has a manufacturer mark. It looks like that I also don't recognize. I'm going to put up data sheets for all these ICs, at least whatever I can find, and hopefully I will know by then what manufacturer that is. And this last IC over here is also a TLO 61 Texas Instruments. All right, so that's it for the Huge Atreides analog weirding module. Interesting effect from Huge, Jeorge Trips. Let's go ahead and put the pedal back together. All right, that was a teardown of the Huge Electronics Atreides. If you have any questions or recommendations for a pedal you want to see on a future teardown episode, let me know in the comments. If you enjoyed the video, I'd appreciate you hitting the like button and subscribing, and hit the notification bell if you want to know when I make a new video. I'm Joe from Graybench Electronics. Thanks for watching.